How are you feeling so far? Anything new that you heard on the conference yet? Good. So let's welcome the next speaker, Andrew from Enix. You need to make some noise. Yes. So the talk looks like an internal holy war, but let's see if we can avoid it and be as nice as the speaker looks. Let's go.
Hello, everybody. Can you hear me? Yeah, I like that you can hear me. I hear myself as well. My speech is about Talos Linux. I would like to introduce it from myself first. I start my Kubernetes experience, 6 years ago. I started as cloud engineer at Vedas. This is biggest Czech hosting company. I was bringing Kubernetes there, and we were deploying Kubernetes on thousands of servers. And I was actually automating this. So I started my experience from that. Then I switched to Pelerg, where we were developing Kubernetes platform DeckHouse. I brought virtualization there based on KubeVirt and storage as well. And since 2023, we founded a company which is called Ionix. We are a startup, and now we provide a solution, open source solution for making managed services. And today I'm going to tell you about the basic part of this solution. We built actually a platform, and the basic part of this platform based on Talos Linux. So I'm start my story from how I get know about Talos Linux. And that's a really interesting idea that I was always had firing idea to build my own cloud, and I want to make it like to have a full feature cloud which has storage, networking, virtualization, and will have and operate always with Kubernetes API and will be totally based on Kubernetes. So this story about that. I found a sponsor. Sponsor said, yeah, I also have some infrastructure. Can you help me to fix your my infrastructure? It also Kubernetes-based infrastructure. And I will sponsor your product. So I say, yeah, deal, good idea. Let's try to do that. When I came, I found that they have really difficult pipeline for preparing new Kubernetes clusters and to prepare deployment for them. It means that when they get new requests for creating cluster, they were running virtual machine or physical servers, then installing operating system on it, then use some automation tool to install Kubernetes. Then that's also not final part. You have to configure Kubernetes somehow. You need to install Helm charts. Those Helm charts were described on GitLab. And every cluster had separate configuration stored on separate repository. That was so difficult. And first I tried to solve this by making this scheme way more easier. So let's try to simplify this pipeline somehow. And the first thing which we can simplify, we can just remove this part of installing Linux. You can use ready-made images and just run virtual machines with these images. You can also simplify this part. You can remove it from this pipeline if you will use Kubernetes-specific OS. So Talos Linux is exactly this system, is Kubernetes-specific system for running Kubernetes. So you create virtual machine. It already has everything need to run your Kubernetes clusters. All the binaries needed. It already has just opportunity to run Kubernetes. That's actually it. Talos Linux is just Linux kernel and few binaries to run Kubernetes. There is no shell, nothing. But you still have this part. This part also can be really simplified by moving this configuration outside to have in single Git repository. And instead of using Helm installation procedure, you can use Flux CD or Argo CD to sync this data to the cluster. So finally, you got this simple pipeline where you got requests, you create a virtual machine, which already has Kubernetes. Inside of this Kubernetes, you have Flux, which downloads this configuration and applies into the cluster. Very easy, and that works really well. Let's see how it works inside. Let's say you have some infrastructure. It can be virtual infrastructure in the cloud. It can be virtual infrastructure in bare metal servers, as well bare metal servers as well. Talos Linux has ready-made images for everything. There are a lot of platforms like bare metal, virtualized cloud platforms. You can download some specific images for every your specific case. For example, I use Proxmox images and OpenStack images a lot. It's just the same Talos Linux, but prepared to run on these specific platforms. It has even more generic ways to install. For example, you can install using ISO or PXE. As well, you can run it as kind replacement using local Docker, for example. So you can just run Talos the same way like you're running kind, just in Docker. It's very useful for some debugging cases and development. Okay, for the initial bootstrap, you need to boot Talos Linux image somehow. If you have virtual infrastructure, you just boot virtual machines with Talos Linux image, and they get booted, but now you have to configure it somehow. And that's a really cherry thing that you can just configure all the system with a single configuration file. So yeah, you can configure the whole system with a single YAML. And this is how it looks like. You have machine section, which describes the configuration for specific virtual machine or physical server, and as well cluster section, which describes the whole cluster. The machine section includes such options like type of virtual machine, type of machine. It can be control plane or worker. It includes certificates for accessing this machine. Those certificates used for Talos, it has separate API instead of Kubernetes API. It's separate API. As well, settings for configuring networking and disk to install the system itself. The cluster section includes control plane, how to access Kubernetes itself, certificates for the Kubernetes, and configuration options for API server, etcd, and other Kubernetes components. To apply this config, you use similar tool to kubectl. It's called talosctl, and you run talosctl apply and apply this config to virtual machine, and it gets configured. Very simple. Nothing else you don't need to do. So to bootstrap the whole cluster, for example, you want to create 3 machines, you can use another approach. First, okay, thank you. So the first thing you need to do is to generate secrets. So you run command to generate secrets file. This is ordinary YAML file which contains all the secrets for your cluster. It has certificates for your Talos Linux and for Kubernetes. Then you can use this file to generate few more files. You use command talosctl gen configuration from these secrets, and you get 3 more files. Talos config, which is used for accessing your nodes, and control plane and worker, which contains the ready configuration file which you can apply directly to your machines. To apply this configuration file, you run talosctl apply, choose a specific file you want to apply, and choose the VM you want to apply. So you can apply control plane configuration to 3 virtual machines just by running talosctl apply 3 times. And then you run talosctl bootstrap. It starts etcd cluster inside of it, and in a while you get ready Kubernetes cluster just in 5 minutes. I know you just applied 3 configs and you have ready Kubernetes out of nothing. To update the nodes, you use the same approach. You just generate new config and you apply it to the same machine. It gets disconnected, update itself, reinstall, and get joined back to the cluster. So the same approach you use for Kubernetes, you use for managing your machines, actually. And to access the cluster, that's a good question. How can you access cluster? Because your clients usually expect some endpoint. You can use this section of configuration file where you specify virtual IP address, which is actually floating IP address. It works the same way like VRRP, for example, but it has another implementation. And this section to generate your kubeconfig file. So using this kubeconfig file, you always can access your machines through this floating IP address. In case if you need to manage nodes, this floating IP will be moved from one node to another, so you will not get lost access. You will not lose access to the cluster. But you can't actually just use pure Kubernetes cluster. You have to configure it somehow, right? You need to install some components, for example, cert manager, some roles, CNI, some monitoring stuff, some infrastructure components. And here I would like to say that Talos Linux works well with FluxCD. That means that you can install FluxCD as specific component which will take all this configuration and apply it to the cluster just as is. You can even integrate it into Talos config by specifying extra manifests. So first manifest you specify to install FluxCD, and the next manifest for applying your configuration. So this way you can use the same configuration file to apply and bootstrap multiple clusters. They will be totally similar. That's very cool, and that works well. That works well with virtual machines. But when you use bare metal servers, that you always have issues. And now we switch to the second part of my presentation, how to manage actually bare metal nodes. Because if you have bare metal infrastructure, you always have some issues like how to manage firmwares, how to manage kernel modules, how to boot actually a Talos Linux image into those bare metal servers. Also, you have to provide right choice to the user, how to choose right disks to install, how to choose correct network interfaces, because every server is different. So let's try to solve that. Firmwares and kernel modules. In Talos world, if you want to boot your physical server, which need to have specific firmwares, you build your own image. You build your own image which contains all the needed firmwares and as well kernel modules. For example, we use DRBD and ZFS for our storage. We can pre-build the image with Talos, which contains all the needed modules right in this ISO file or initramfs, which is ready to boot. To build this image, you have another YAML spec where you can specify which firmwares you want to and which kernel modules you want to. And then you run Docker command which outputs to ISO or to specific format, which you can use to boot your system. How can you actually boot your Talos Linux on bare metal nodes? Of course, you can use the more generic way for installing using ISO. So you can generate ISO, connect to your server, then boot it, then configure some settings for network, then use talosctl to apply those settings, to apply your configuration, cluster configuration to this machine. But obviously, it makes more difficult if you have more servers. It's difficult to manage all of them because too many manual operations. I more like the way you can use PXE booting. In this way, you just need to have two servers, DHCP and PXE. They can be even temporarily just for bootstrapping the nodes. And then you can boot your bare metal infrastructure. They will be automatically booted from those servers. They will download this image just out of nothing. At Ionix, we actually replaced this part with ready-made Docker images, which already contain our built image with all the kernel modules and firmwares. And the question is how to provide the choice to the user, how they can choose the right disks to install and right interfaces to use. Because we remember that every server is different. Okay, and here we developed our own method, which is based on same talosctl approach. And it's called Talos Bootstrap. First, you boot your nodes. They get booted into maintenance node. The next, you can use Talos bootstrap script to bootstrap every node in the cluster. First, you bootstrap the first node, it gets ready, and bootstrap it etcd. Then you can use it to join other nodes into the cluster, into the same cluster. Let's see how it works. If you can see, it can remind you old school Debian installer, but it works right in PXE, so you can run this script and it will find all the nodes in your network ready to bootstrap. Then choose the node, enter name, choose disk to install, put some network settings, even put some virtual IP address. So finally it generates this Talos Talos configuration file, which you can apply, and you see it graphically. So you just repeat this few times. In 5 minutes, you can get a ready cluster, ready to use. If you look inside, you'll see that it uses the same image with pre-built kernel modules and all the needed firmwares we want to support. And this allows us to make a stable layer for our platform. And here, I would say that our platform consists of few layers, and this layer is more important for us because we want to provide it to our customers, and they always have different hardware, and we want to be stable. We actually remove this operating system just by using Talos Linux and run Kubernetes directly on hardware. And our platform is called Coist, is based on this approach. So let's switch to the next part of my presentation about platform building. And I would like to introduce about our platform, why is it needed for. This is actually Coist, this platform which allows you to order managed services. It is totally open source and based on open source technologies. So we based our platform on Kubernetes and Talos Linux and allow to run virtual machines, tenant Kubernetes clusters, various databases, Redis, Postgres, and things like that. So we need stable base for make it running with the storage, networking, and how it works. We have layer 1, which is provided by Talos Linux. It already contains some Linux kernel, and because our components, especially storage, it depends on some specific kernel models and their versions. And we can guarantee that it will always work in this operating system. Networking also depended on the kernel version. It's based on OVN, and virtualization, which is KVM based. It's KubeVirt project, which allows you to run virtual machines right in Kubernetes. The next layer allows us to bootstrap the operators, cluster API, and monitoring. And the latest layer is application layer, which allows this to run these components by our customers. So they have this dashboard where they can choose and install some services. So the first part is done by Talos Linux. The second part is based on Flux. And the latest part is this nice Kubernetes dashboard. It is actually also based on Flux CD. But never mind, I just want to provide you information how we build platform itself. So the approach for installing this platform is also a little bit different. So we don't use Git repository because we want to have some versioning. So we provide our customers a simple interface to install it. So you just use kubectl apply to empty cluster, and it bootstraps itself. How it works? It just creates container which contains Helm charts, and also it installs Flux CD. Then Flux CD installs those Helm charts from this container to the Kubernetes itself. To update these components, we just run another container, and Flux CD just applies new configuration. So we can guarantee that every time when we providing new version of platform, all the components will work stable at the same versions. But the good question, as you probably heard, that Talos Linux has no shell, it has no SSH, but how to debug it? That's a reasonable question. And here I would say that Talos Linux has a lot of tools or API calls which you can use to debug system itself. The API daemon runs not inside of Kubernetes, but it run a specific binary, and when you call it, you can collect some network statistics, you can see kernel logs, you can make packet capture. So a lot of opportunities already made out of the box, and you can do that directly from your machine, which is really useful. But sometimes it might be difficult to make even more deep backup debugging. And here I would say that we have this nice plugin, kubectl nutshell. If somebody uses it, please raise your hand. Yes, that's so cool. Many people using it. I wrote this plugin, and for Talos Linux, it has specific mode. It's called Xmod. It allows you to exec into specific. So when you run nutshell, you specify node you want to debug. You get shell into this container. It's privileged container. It has mounted host namespaces. So you have an ability to speak with CRI. You can debug networking, and it is really useful if you need to have a ready environment. If you want to have known interface to debug, actually shell, to get a shell, you can use this method for debugging. But it still allows us to keep our system stable, so you can't actually affect on the system. You can put some binaries which will affect CRI and some operating system layer. So conclusion. Finally, we got environments which are unified and reproducible for every customer. And this is really useful because we can provide our platform to someone without having access to their infrastructure. We can be sure that if something is going wrong, where exactly the problem, because we have exactly the same infrastructure with same kernels, same modules, and same components. We provided simple interface for installation, and because user experience is really important for start using our solution. Users knows how to install this system. It is pretty similar to Debian installation, and we provide opportunity to debug it, which is useful for them. And our platform covers all the infrastructure stack, so you don't need to think how to solve virtualization, how to solve storage. We just provide a single installation script which runs the platform and has all the features enabled. And we are totally open source. You can find our project on GitHub. The links I'm going to provide you is first link to Talos Linux, the second link to Coist platform, the solution we develop, which you can try and install in 5 minutes. And the last link is to Kubernetes.io articles I wrote last time. This is how we make Kubernetes in Kubernetes. So we run tenant Kubernetes clusters in this management Kubernetes cluster, which we run by Cozy Stack. So that's it. I would like to say thank you to everyone who helped me to prepare this nice presentation. And please leave your feedback. I'm ready to answer any of your questions. Thank you.
The microphone is running. And I think we lost our helper.
Am I finished too early?
Hello, thanks for the talk. You were killing my questions that I have in my pocket initially, but there is one left. Regarding CNIs, for example, Cilium has some dependencies on kernel models. You said that there are just 12 binaries in Talos. Yep. Am I right that it is fully supported in case of Cilium, in case of Calica, like the two most famous CNIs we have on the market? It has either IP table stack or a BPF stack. Is it supported?
Yes, we use Cilium by default. We actually use two CNIs. We use KubeVN for virtualization needs. But we also use Cilium because we love Cilium and we use it for services network. Actually, our platform has options to install in different ways. The first thing I tried to describe you that you can use it for managed services, but you can also use it for Linux as Kubernetes distribution. And for the second case, we use Cilium by default. So yes, we support this configuration and we use it.
Thanks. And all of the security features are supported. I mean, security features of Cilium.
Actually, all the platform is built out of Helm charts. So you can specify exactly options you needed, and they will be supported. So the value of platform that we provide stable environment of open source components which works together well. But there is still an opportunity to customizations. And we also have community. We have open meetings for development. So anybody can join and develop their own solution based on this. We want to join people together to work on the same platform. We actually want to donate this project to CNCF. So we even will not have on, when you're donating project to CNCF, you have to provide all the rights to the code and logos. So yeah, we want to build a nice open source product together.
Thanks you, and good luck to be graduated. I mean,
Thank
CNCF
you.
graduated.
Thank you. Now this scary moment because this guy is also a speaker and he will ask a question.
I have a simple question. Is it easy to replace the Linux kernel in the Talos image? Like if I want to run a custom Linux kernel.
Sorry, I didn't get it.
Is it easy to replace the Linux kernel in the Talos image?
Yes, actually, you can use your own kernel module, your own kernel. Actually, there are 3 repos for building Talos Linux. And you can specify kernel config you want to, so you can use vanilla Linux. Or you can also replace it to your own custom image. I think it will not take as much time.
Okay, thank you.
Thank you. You told us about the platform to make some cloud and PaaS service. I'm wondering about the scale and load that such platform can give to its clients and users. Does it allow to scale like Google Cloud, Azure, or it's for some small use cases?
Right now, we started from beginning, so we don't have exactly big installations, but we have experience with that. For example, at Vedas, I was managing thousands of nodes, and I know how to grow. For now, we have no such opportunity to check if it's possible to scale at thousands of nodes. But you can check exactly projects we use. So KubeVirt has opportunity to run at this amount of nodes. I have concerns about using KubeOVN, but I think they also have an opportunity to run at least for 500 nodes. And we, of course, can be scaled horizontally, so you can create multiple availability zones, which will not be connected to each other directly, but you can still have the same management interface.
Thanks.
Okay. Watch me running.
Thank you, Andrei. The question is, you showed us how to bootstrap one node in your system. How can we automate the bootstrapping of many nodes, hundreds of them, in virtual space and in hardware?
That's a good question. We are not highly dependent on our installation method. We actually we don't even depending on Talos Linux. But if you use Talos Linux, there is just way how you boot this Talos Linux on various nodes. They provide a nice option to use Omni. It's a service which allows you with web interface which allows you to bootstrap Talos on multiple nodes. And I think that you can buy it from Cider. It is not open source. It is on the same license under BSL, but you can still use various options. For example, Matchbox. You can use Matchbox and put a Talos configuration into it. So you just boot multiple nodes and they get joined together. So that's the question. To answer to this question is how to boot Talos Linux on multiple nodes. There are multiple ways.
Andrei, thank you for the presentation. I see you're providing a full stack platform, so ready to go, right? I come and I download, initialize, and I get working Kubernetes. So I have a request / question. Usually these systems require some kind of application performance monitoring tool installed, or maybe logging collectors. I see you have monitoring, but do you have those two as well?
I would say that we provide multi-tenant system, and we have really nice system of tenants. So you can run separate monitoring stack for every tenant. And under this monitoring stack, you can run multiple clusters. And right now, it is not implemented yet, but the configurations and monitoring and logs from those clusters will be connected to specific monitoring hub. So you can run multiple monitoring hubs, just an application, just click and install, and then you run services. All these services get collected into this.
So the hub is not included.
Oh, sorry?
The hub is not included.
The hub is not?
The hub that collects metrics for monitoring.
The hub is implemented already. So we run Grafana with on-call. We not collecting alerts yet, but we will start doing that soon. And we have ready-made dashboards. The thing is not implemented is to running multiple monitoring stacks and start collecting metrics from all separately. But it is in design. So yes, you actually can run multiple monitoring hubs, but the applications will still running, putting logs and metrics into a single stack.
Okay,
but
thank you.
That's the thing we're going to solve in a while.
Andrei, thank you for this beautiful presentation, but I think my question is connected with the previous talk. You showed us this beautiful dashboard where we can install these applications, but the question is it possible to, let's say we have some teams and one team needs one set of this application, another team another set of application. Can we isolate them? Can we group some of them into groups?
By default, the configuration by default intends that your namespaces will be isolated. We have tenants, and every parent tenant can spawn multiple child tenants. Parent tenant can manage child tenants, but don't have access to it by default. In this form, you can have separated environments for every team, but you can still have some common services, for example, common monitoring hub or common ingress or common storage for Kubernetes, which will join them together. We want to make some opportunity to join those environments, those VPCs actually between each other, but it is not implemented yet.
Okay, thank you.
Thank you very much for presentation. Very interesting. So my question maybe is not about your platform, but the Talos Linux itself. I don't know if it's mature enough or not at this stage. So what about hardware support? For example, I doubt that NVIDIA, for example, provides drivers for GPU cards or Mellanox, network cards for Talos. What do you think about it?
That's a good question, and this configuration is supported by default. So NVIDIA has drivers. Talos Linux actually implemented official extension for NVIDIA drivers itself. So you can just put it into the same image, and you boot your nodes. They have all the needed drivers for NVIDIA. Then it's just about how to use it inside of Kubernetes. The question is, do you need any operator for that? Yeah, please take a mic because it will not be recorded.
Sorry. I mean, NVIDIA operator for GPU is not supported, right? To automatically mark nodes for GPU, discovery GPU, for example, and something like that.
That's the same Linux. That's just question of what the kernel modules you put there and how you're operating with them. If you need to run some GPU nodes, it's not a problem. You just build image which includes NVIDIA drivers. Then you run inside of Kubernetes, you apply this NVIDIA operator, or I don't remember what exactly the thing, resources operator, which adding these virtual cards for the NVIDIA. And KubeVirt also supports this. So you can use it for running virtual machines with GPU, for example.
Okay, thank you.
And any more questions? Okay, could you pass the mic?
Thank you, Andrei. How to use link aggregation, network link aggregation? If a bare metal server already installed and link aggregation already configured on the network switch side, how to boot and install Talos Linux?
What do you mean? You mean LACP?
LACP, yes.
Yes, we support it in our configuration method. So by default, it allows you to choose bonding and provide options to install. If you have very specific configuration, Talos Linux also supports that. You just need to check spec of this YAML file. You can describe all the network configuration inside of it.
Okay, thank you. And another question, how to use disk encryption? How to pass the encryption password to the Talos Linux securely?
There is no any passwords. The basic security model intends that you have just certificate and you use like TLS authentication for talking to the nodes. If you want to provide some regular access to your nodes, you have to cover it with your own API. But by default, you have this client certificate, server certificate, and CA, which you can use to access it.
Okay, thank you.
Which you trust, yes, this word.
And the final question. There you go. I'll get the mic in a minute.
Thank you. I have a question. If we want to install non-vanilla Kubernetes, or for example, OpenShift, we can use for this case Talos or not?
To be honest, I'm not sure about OpenShift, but if various Kubernetes distros can be installed on vanilla Kubernetes cluster, I think they can be used with the Talos Linux as well. So it provides you almost vanilla Kubernetes cluster with few security options enabled by default, but after all, it is vanilla Kubernetes cluster, which you can use the same way everywhere.
Thank you, guys. It was amazing. I felt like a CTO in a startup, and my team went out for lunch, and I'm just writing all the code. But no problem, I can still do it. So, before we ask the speaker to go to the discussion zone, please scan the QR code and give feedback on the talk. If it didn't work the last time, it should work now.
Yeah, if I'll get enough feedback and good feedback, wait for the next talk, which will be about the next part of this stack about virtualization, Kubernetes and Kubernetes. I think it will be on the next Tech Internals Con.
Super. So, a big round of applause. Thank you very much.
Thank you.
So, my colleagues will take your microphone, and then please proceed to the discussion zone. Have a nice day, guys.